hello everybody. In my last video I make some paper battery which was activated by water. And this kind of battery was really interesting and also really fun to make. But now is the question if I can make some rechargeable paper battery based on the same concept which I make with paper battery from my last video. So for this reason I need to use some paper and at least 2 inks. But to make some rechargeable paper battery I need to make some small changes. For example, the electrolyte. The electrolyte which I used in my previous video, I used this salt water. And instead of this salt water, I will use 2 mole of zinc sulfate. Actually, you can use some another electrolyte, but in my case, I will stick with this 2 mole of zinc sulfate. And then I also need to change the positive cathode ink for making the positive electrode. Because in my previous video I used this graphite ink, and instead of using this graphite ink I have here the option 1, and this ink is made from activated carbon. So to make this ink I use PVB for the binder, some ethanol for the solvent and activated carbon for the active material, and I also put some small amount of carbon black for increasing the conductivity. Like I said, this is the first option. The second option is this ink. This ink is this manganese dioxide ink. And this ink is made on the same way which I make all these inks. The ethanol is the solvent, the PVB is the binder, and the active material is this manganese dioxide. And the manganese dioxide which I use in this ink, I collect from this AA zinc carbon battery. So the zinc carbon battery have the active material which is some mix of manganese dioxide and carbon black. So I collect this black stuff which I found in this zinc carbon battery and I make into this ink. The negative electrode for this rechargeable paper battery is still the same, and I use this zinc ink. This is the ink which uses some zinc powder. And now to make this rechargeable paper battery, I make on the same way which I make with the paper battery from my last video. I use some ordinary paper, which I put into this 2 mole of zinc sulfate electrolyte. I leave the paper for a couple of minutes, and then in the end I dry it. So on the one side I paint the negative electrode, and I use this zinc ink. On another side of the paper I use this activated carbon ink and I paint the positive electrode. And actually that's it. So everything is fine. But now in this stage I get the problem. Because here I have already made 3 samples. And this kind of paper batteries are rechargeable, and for this reason before use you need to charge these kind of cells. And charging some paper battery without any external current collectors is a nightmare, because the cell will have too high resistance and the charging efficiency will be really bad. That's why I make here 3 different samples of these rechargeable paper batteries. So the first one, here is the positive side, here is the negative side, and on each side I also put this aluminium tape to make a good contact between the active material and this tiny current collector. But still this kind of cell was not good, because with this design I still get too high resistance and the charging efficiency was really bad. The second option was this. On one side I paint this positive electrode, paint with this activated carbon ink, and on another side I make this negative electrode which I paint this zinc ink, and on this paint I also put this zinc foil current collector. And still this kind of design was also not good because still I get too high resistance. And the third option was this. Again, here I paint with this activated carbon ink for the positive side. For the negative side I use this zinc ink, and on each side I put some external current collectors, which is in basic some graphite. And with this design I was able to charge the battery. So because here this design of this cell is the positive side is made from activated carbon and the negative side is made from zinc. The electrolyte is this 2 mol of zinc sulfate. That's why for this reason this cell is some zinc ion hybrid supercapacitor. And you can get good amount of information about zinc ion hybrid supercapacitor on internet. Okay, now this cell is already dry. I need to put into the electrolyte. Okay. If I try to charge this cell without external current collectors, then in this case the charging current is 10 milliamps or lower. The charging voltage which I use is 2.1 volts. But now I will put these external current collectors to increase the conductivity. And now actually I'm able to charge this cell with 70 to 60 milliamps. So because this cell is some zinc ion hybrid supercapacitor, the cell voltage of this one is 1.8 volts. And for this reason I can use only one cell to light up this LED. Really nice. So right now I have here some paper zinc ion hybrid supercapacitor, so to say. So the capacity of this kind of cell is, how to say, moderated. It's not good and it's also not really bad. I mean, this kind of paper batteries you cannot use in any big applications, but can fit in some ITO RFID applications area, for example. So guys, that's it for now and we see us in the next video. Bye.